Today's video will focus on adding and subtracting rational expressions, but before I go through the notes, I'd like for you to attempt numbers 1 through 4 as a warm-up. So go ahead and pause the video and hit play when you're ready to begin. When we're adding or subtracting fractions, the first thing we need to check for is that they have a common denominator. If they do not have a common denominator, we will not be able to perform the indicated operation. So if I take a look at number 1, they do have a common denominator, so I can go ahead and add the numerators together. This becomes 1 plus 3 all over 5, or 4/5. For number 2, once again, they also have a common denominator, so I can go ahead and subtract. 6 minus 4 is over 7, or that's 2/7. If these fractions could be simplified any further, we would also like to do that, but it's not applicable in these two cases. Take a look at number 3. This time we do not have a common denominator. We have a denominator of 5 and a denominator of 15. So you need to ask yourself, what can we multiply one or both of these fractions by in order to get the same denominator? Well, a common denominator that I know they can have is 15, because I can multiply 5 by 3 to get that 15. Now, I can't just multiply the denominator by 3. I have to multiply it by 3 over 3, because this technically is equivalent to 1. So when we multiply something by 1, we're not actually changing the value at all. If we multiply our first term by 3 over 3, we'd get 2 times 3, which is 6, and 5 times 3, which we said was 15. And we're just going to add that to the 7/15. Now that we have a common denominator, we can go across the top. And 13/15 would be our answer. Number 4, once again, we do not have a common denominator. Now, this one's not as easy, because I can't just multiply one of the numbers by something in order to get the other. For example, let's say I was looking at the 8 and wanted to ask myself, what do I multiply 8 by to get 12? Well, nothing, because the multiples of 8 are 8 times 1, which is 8, 8 times 2, which is 16, 8 times 3, which is 24, so on and so forth. The factors of 12 are 12 times 1, which is 12, 12 times 2, which is 24, 12 times 3, which is 36, so on and so forth. Now, I stopped here because I noticed what their common denominator could be. So the least common denominator that they're going to have is 24. I have to multiply the 8 by 3, so the second term will be multiplied by 3 over 3. And I have to multiply the 12 by 2, so the first term needs to be multiplied by 2 over 2. If I do that, 2 times 11 is 22 over 24, minus, I have 3 times 3, which is 9, over 8 times 3, which is 24. Since they have a common denominator, we can now combine it. 22 minus 9 would give me 13 over 24. Alright, now, the reason why I had us do this as a warm-up is because, as with numerical fractions, which is what we did here, the procedure used to add or subtract two rational expressions depends whether upon the expressions have like or unlike denominators. For example, when we're adding or subtracting in example 1, both examples already have common denominators. It's really, really nice when this happens, because if I have a common denominator, I don't have to multiply the terms by anything, I can go ahead and perform the operation. So this whole thing's going to be over x plus 3, and I can go ahead and add. So I have 3x plus 2x plus 1. Then you'd want to combine like terms. I can combine my 3x with my 2x to get a 5x plus 1. Always make sure that it's simplified all the way. So when I take a look at my numerator and denominator, I can't factor, I can't simplify anything, so I'm going to leave it like that. I had a couple students ask me why I can't cancel out the x's. Well, I can't cancel out the x's because I have addition here, okay? These are expressions. There are two things that go together. So it's 5x plus 1, that expression, x plus 3, that expression. We can only cancel stuff out when we are multiplying or dividing, okay? When we have addition or subtraction, we cannot do that. Take a look at part B of example 1. Once again, we have a common denominator, so I'm just going to leave the whole thing over x squared plus 2. Now, I'm going to circle this or star this because I usually see sign mistakes when we have subtraction. We are subtracting this whole expression. So you need to make sure that you are subtracting the first term and you are subtracting the second term. Any other terms that it may have in that second numerator. So really what this becomes is I'm going to keep my first term, 2x minus 1. That numerator stays the same. But I am subtracting 4x, and I am subtracting a positive 1, which makes it minus 4. If I was subtracting a negative number, it would have become a plus. Okay. Once I have that written down, I'm going to combine like terms. So I have my 2x minus 4x, which is a negative 2x. And negative 1 minus 4 is a negative 5. All over x squared plus 2. I'm going to check and see if I can factor it any further and try to cancel stuff out. Technically, I could pull out a GCF of negative 1 in the numerator, but that's not going to help me cancel anything out at all. So nothing factors further. That's going to be my final answer. Let's take a look at example 2. So all we're going to do for all of these is just identify what the least common denominator could be, because this is where I see a lot of students struggling. Okay? So keep in mind, we're just looking at terms that would be in the denominator. What we need to do is ask ourselves, what can we multiply by to get them to look the same? If we have monomials like this, we can take it one step at a time. So I'm going to look at my constants first, 2 and 3. Okay, 2 and 3. The multiples of 2, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 4 times 4 is 8, and I can keep listing them off. 2 times 5 is 10, and then 2 times 6 is 12, so on and so forth. Okay? If I think about the multiples of 3, 3 times 3 is 1, or excuse me, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and I can just keep listing them on. If I want to identify the least common denominator, that's the smallest multiple that they share. So if I take a look, a common multiple would be 6, and a common multiple would also be 12. Now I want to pick the smallest one. That's why it's called the least common denominator. So I actually will want to use the 6. Because I'm going to end up multiplying the 2 by a 3 to get 6 and the 3 by a 2 to get 6. Now when we're looking at variables, so x cubed and x to the 5th power, normally with GCF we would say use the lowest power. But when we're using least common multiples, I want you when pulling out variables, use the highest power. Because we can always multiply a smaller power by something to get that higher power. For example, I can multiply the x cubed by x squared in order to get the x fifth. But I can't multiply x fifth by anything to get x cubed. I would have had to divide. So again, I want to use the highest power. Which means when I look at the y's, which one's bigger? Y to the fourth power or y cubed? Y to the fourth power. So that's going to be my least common denominator. This is the process when I use monomials, okay? That means that it's a polynomial with one term. There's no addition or subtraction. Whenever we do have addition or subtraction, so like what we have over here, we need to factor first. Only after we factor can we identify what the least common multiple will be. Starting with part B. If I were to factor x squared plus 3x minus 4, this is guess and check. So my factors of 4 are 1 and 4, 2 and 2. That negative means I must use different signs, and I want to get to a positive 3. So using different signs, I need to have a negative 1 and positive 4 to get my positive 3. So x minus 1, x plus 4. Okay? Now, if I were to factor x squared minus 3x plus 2, I once again am going to use guess and check. So the only factors of 2 are just 1 and 2. And because it's positive, I know I want to use same signs. Since I want to get to a negative 3, we need to use negatives on both, meaning that the factored form is x minus 1, x minus 2. So now, when you're trying to identify the least common denominator of expressions, you want to write their similarities first, okay? So x minus 1. We're going to multiply their similarities by their differences, so that way everything's included. I don't want to write down x minus 1 twice, because then I'm going to make solving a whole bunch more difficult than it has to be. And technically, if I put x minus 1 times x minus 1, that's x minus 1 squared. I don't see an x minus 1 squared here, so I can't do that. Okay, so I put their similarity. Now I need to multiply by their differences. So an x plus 4 and an x minus 2. Let's try that again, because it's going to take some practice. The first thing I need to do is to factor these. Hopefully you notice that for part C, this is a difference of 2 squares. That would be A is x and B is 2, because x squared is x squared, 2 squared is 4. Difference of 2 squares would look like this. It's x plus 2, x minus 2. And then if I were to factor our trinomial here, this is a case 1, since A is 1. I can use guess and check. The factors are 1 and 6, 2 and 3. Now technically, both of these sets could get me to a positive 5, but because it's a positive 6, I know I must use same signs, meaning that the 1 and 6 will not work. I will have to use a positive 2 and a positive 3 to get that positive 5. Okay? Once again, when we're trying to find the least common denominator, we want to first multiply by their similarities. So what do they both have? Well, they both have x plus 2. And then we're going to multiply by their differences. So this one has an x minus 2, and this one has an x plus 3.